Lesson 120, number 8, it wants you to solve the system of equations using inverse matrices. If you need more information on inverse matrices, you can go back to the lesson that it came from. I'm just going to kind of show you how to do the problem. So first you're going to take these coefficients here and write them as a matrix, and then multiply by x and y. This part right here is just a way of rewriting this, because negative 3 times x plus 2 times y, right, equals negative 11, and it's just another way of writing this. Okay, so now I want to multiply. Instead of dividing both sides, we don't divide in matrix math, we only multiply by the inverse. So to get rid of this matrix, I want to turn it into what we call the identity matrix. And the way to get the inverse matrix that I can multiply both sides by to get the identity matrix would be, you take these two numbers and switch them. So see what I did? I put the negative 4 up here and I put this one down here. And then you take these two numbers. It looks like I switched them, but I didn't. I just changed their sign. Okay, so the diagonal that goes from top left to bottom right, those two numbers switch places, and then the other diagonal, you just change the signs of the number. And then where did this 1/16 come from? That came from the determinant of this coefficient matrix. So negative 3 times negative 4 is 12, minus negative 4. So 12 minus negative 4 is 12 plus 4, that's 16, and then you take the reciprocal. And then that number has to multiply all these numbers. So 1/16 times negative 4 gave me the negative 1/4, and then 1/16. Basically, you can do it in your calculator, or you can use decimals if you want to. I was able to do some of the fraction math in my head, but basically I multiplied 1/16 by each of the four numbers, and I got my 4 fractions. And then now I know that's the inverse matrix that'll get rid of this matrix. Those matrices cross out. Actually, if you want to check and make sure you didn't make a mistake on getting your inverse matrix, you can multiply them out. You can go negative 1/4 times negative 3, well, that will give you 3/4, and then negative 1/4 times, wait a second, it's too bad I can't use both hands, I have to hold the iPod. That times that, plus, this is row 1, column 1. That times that gives you 3/4. Plus that times that. That gives you 1/4. 3/4 plus 1/4 equals 1. Now if you do that same procedure and multiply everything, then you'll get this matrix. Okay, and then when you multiply that by x and y, 1 times x is x, plus 0 times y is just 0. And then if you do that for y, you'll just, this whole thing times this whole thing equals x, y. Okay, so basically what you did is you got rid of that the coefficients right here. Okay, and then over here what happened? Well, this was my inverse matrix, and I'm going to multiply it by the right hand side of the equation. It's important that I put it in front and not behind, because the order matters. When you're doing matrix multiplication, it is not commutative. Okay, so you go that times that plus that times that. So I did it all out because it was fraction math. I couldn't really do it in my head. I went negative 1/4 times negative 11 gave me that number, and then negative 1/8 times 14 gave me that number, and then I did 1/8 times negative 11 to give me that number, and that times that gave me that number. Now I had to add these up, so I got the common denominator. Actually, I reduced this one and got the common denominator. And when I added, that take away that, I got 1. And that take away that, I got negative 4, and that's the answer.